A cork floats to the outside of a glass of water and stays there because water molecules are attracted to cork as well as to the side of the glass. Water moves up the side of the cork, and surface tension pulls the water surface and cork to create the smallest area on the side of the glass closest to the cork. If you fill the glass up so that the water no longer has attraction to glass sides, the cork will float about in the water. Water is drawn up a small capillary tube because of its attraction to the sides, forming a meniscus, meaning the curved surface within the tube. A pin placed between two microscope slides, wrapped in a rubber band, will create a void in between the slides of increasing spacing from the closed side of the slides towards the pin. Placing the slides into some colored water demonstrates the strength of capillary action between this spacing, forming a good curve. The shape of the meniscus is determined by the amount of attraction to the side of the tube and the surface tension of the liquid. This may also change depending on temperature. Different materials as capillary tubes have the effect of different amounts of liquid being drawn. The smallest capillary tube that I have is made from a different material than the other tubes, and the height of water drawn is larger at higher temperatures. Liquids other than water will be drawn to different heights depending on the adhesive and cohesive properties of that liquid at the specified temperature and how close together the sides of the capillary tube are. Mercury descends in a capillary tube, forming a convex meniscus because of greater cohesive forces. Capillary action also can be demonstrated using blotting paper, which is a type of adsorbent paper. Adhesive forces attract the water to the paper, and cohesive forces continually draw water from the surface of the liquid. It takes different liquids different times to travel up a piece of blotting paper, and consequently a mixture of liquids can be separated in this manner. This is known as paper chromatography. One can place small dots of different substances, such as tea, tomato sauce, and different types of ink, onto pieces of filter paper, and separate different components by waiting for the solvent to travel up the paper, drawing with it soluble substances, which it dissolves from the dots. The solvent could be water or another liquid such as methylated spirits. The most pronounced effect occurs using water as solvent on the black marker of a certain brand of water-soluble brush pens. The structure of chalk is that of a solid with very small porous cavities inside. A piece of chalk left in a solution of potassium permanganate also exhibits capillary action. The liquid manages to penetrate right into the very center of the chalk, as demonstrated when the chalk is snapped in half. Capillary action is also used in kerosene and other spirit burners, which use a wick that draws up the fluid towards a lit end. The time taken to draw up the liquid and the size of the wick determine the size of the flame and the amount of heat given off.